Section 1.3, using midpoint and distance formulas. So those are the formulas we'll cover today. We're going to kind of explore where they come from. How can you find the midpoint and length of any line segment in a coordinate plane? So that's our essential question. And looking down at exploration 1, this is what a coordinate plane is. A coordinate plane basically has two axes, the x-axis and the y-axis. And I know that you've spent some time in your prior classes exploring that, so hopefully you're pretty familiar with it. Okay, so we're going to do part 1 first. We're going to find and plot the midpoint. Well, the midpoint is going to be in the middle, right, between these 2 points, A and B. So if I'm looking at A and B and I'm trying to find the middle of them, I need to figure out, it's a little bit tricky because it's a diagonal line. It's a lot easier to find the middle. Like if I were to give you some segment and I asked you, it's a horizontal segment, and I asked you to find the middle of that, and maybe you knew that this was at 0 and this was at 6, then you would know that the middle was at 3. Same with a vertical line. If it's a vertical line, it's pretty easy. Again, if I say that just for ease here, that this is 0 and this is 6, yep, midpoint, it's 3. 3 up, 3 down, 3 right, 3 left, okay? We know then that this is going to be at 3. What's a little bit trickier with a diagonal line? How do you truly find the midpoint? And there's several ways to do this. And just exploring, let's see one way. So one way that you can do this is you can look at, what was your true rise and what was your true run to get from one point to the other. And notice I just used those words rise and run. What does that bring up in your mind? Hopefully you're thinking to yourself, slope. So to represent slope, we usually use a lowercase m. And we know that slope is always rise over run. But what does that really mean? Okay, so to go from B up to A, I would need to rise a certain amount. I would need to change from one y value, right, -2, to the next y value, which is +4. So your rise is really this change in y. This little delta, that's a Greek letter, and that means change. I'm going to use it often. So that would give you your change in y, and now your change in x is the other part of this. It's that horizontal piece that goes from -5 on the x-axis to +3 on the x-axis, and that's going to give you your change in x. So I think if I could figure out how much I go up and how much I go over, then I could maybe cut that in half, and I could find my midpoint. Now, the way that we figure out how much we truly go up is we look at our y coordinates. We look at 4, right? We're on the y-axis at 4. And then we look down here at our other one, which is -2. So what we really do is we take two y values, like y2 minus y1, and we subtract them. It doesn't matter which one you call which. You just have to be really consistent with that. So, for example, if I call this y2 and I call this y1, then I would have to call this one x1, and this point would involve x2. So the subscript should be the same. So I would do the same thing with my x values, so that way I can find the middle of it. Okay, so let's go ahead and let's do this. If we just go ahead and use slope, let's see if we can find where the midpoint is. So let's take y2, which is 4, minus y1, which is -2, and put that over x2, which is 3, minus x1, which is -5. Well, a minus and negative, those become positives. So I'm ending up with 6/8. Or if I reduce that, dividing top and bottom by 2, I then end up with 3/4. which would mean that from B, I would need to go up 3 and over 4 to get to the midpoint. So let's see, if I go up 1, 2, 3, because that's halfway, and then go up or go over 1, 2, 3, 4, that puts me right here. Now let's see if that's the same coming from this point. Now notice for this one, I'm going to have to go down and backwards. So that's still going to be negative, negative. I'll talk about that in a minute. So I'm going to go down 1, 2, 3, and over 1, 2, 3, 4, or backwards 4. So if we look at like individual slope triangles, let's see, from B to, I'll call this midpoint M. Then I went up 3 and I went over 4. Well, from this, I went down, if I do a similar slope triangle, I went down 3 and I went backwards 4, which gives me, I'm going to just draw a little line there. Now, negative 3 over negative 4 is still positive 3/4 because a negative divided by a negative is a positive. And in fact, this does end up being our midpoint, right? I went the same up, same rise, same run, same rise, which happened to be negative, same run, which happened to be backwards. Puts me at my midpoint, which ends up being negative 1, 1. So that's one way, is using slope. Let's see, I'm going to highlight this. So this is the formula for slope. You're going to want to know this until you're ever done doing any math classes. Actually, probably even after when you have children, you're going to still need to know that because you're going to need to share that with them. Okay, so let's see. Another way that we can look at this is we can average the x values and the y values. It's going to give you the exact same thing. So if I think about averaging, let's start with my x values. So here I'm at negative 5, and over here on my x values I'm at 3. So I can actually take those two x values, add them together, divide by 2. That's going to give me the average of them. That's going to put me right in the middle. So another way to do this is to take your x values. So I'll start with x values. Negative 5. My other x value was 3. And divide that by 2. Let's see what I get here. Negative 5 plus 3 is negative 2. Over 2, look at that. I got negative 1. That happens to be the x value of my midpoint. I'm also going to do the average of the y values. So now, looking at the y values, take these two y values and average them. So I'll take negative 2 plus 4, divide by 2. That'll equal 2 over 2, which equals a positive 1. So you can see my x coordinate's negative 1, my y coordinate's positive 1. So that is exactly where my midpoint is. So you had two ways of doing this. One is to use the slope. One is to use the average. This is actually the midpoint formula is based pretty much on this, finding the average of the x's and the y's. Okay, but I'm going to go ahead. I'm going to go back here just because I had the slope. I want to highlight your slope triangles. So from B, I went up 3 over 4 just to show you the slopes where they're coming from. And from A to M, I went down 3 and backwards 4. So that kind of gives you a little visual, little highlighted visual of it. All right, next one. We're going to add C, which is 3-2 to your graph. Or sorry, 3 negative 2 to your graph. I don't know why I said dash. So we're going to go over 3 and down 2. So this will be point C, and it is 3 negative 2. We're going to use the Pythagorean Theorem to calculate AB. Okay, so I'm going to draw a nice triangle here because Pythagorean Theorem involves right triangles. Okay, so I need to have a right triangle in order to do this. Okay, so I'm going to go from B to C, and then I'm also going to go from A to C. And then you can see that you've got BC as your longest side. Now, Pythagorean theorem is something that hopefully you've learned in the past. Pythagorean theorem says that I can take the leg of any right triangle and square it, add that to another leg of any right triangle and square it, and that will in fact give me the hypotenuse squared. Now, the hypotenuse is always the longest side of any right triangle. So this is a right triangle because I've got one leg is vertical, one leg is horizontal. They meet at a 90-degree angle. The side opposite it then is your hypotenuse. This is going to be your longest side. Well, I don't know the length of either one of these legs, right? So the first thing I have to do is I have to find the lengths of the legs. So that's what this asks. What do you need to do before you can use the Pythagorean theorem? And we need to find, so first, find length of legs. Okay. Now we've already done that actually because we also drew this right triangle up here and we knew that this length up here was a certain length and this one was a certain length as well. I'm going to show you how to do that using, if you remember that ruler postulate, where we basically can find the distance between any two points on a horizontal or a vertical line. So to find the length of BC from B to C, this is a horizontal line. So I subtract, or I take the difference between the x coordinates. So what I'm going to do is I'm going to subtract the x coordinates. And I want to make sure that it's positive, so I'm going to do absolute value. Okay, so the x coordinates are 3 and negative 5. So I'm going to take 3 and subtract from that negative 5. Well, that's really the same thing as 3 plus 5. So that's the absolute value of 8, or just 8. So that's the length of this side. It's going to be 8, which we had already counted up here. And you're totally welcome to count. The problem's going to be you're not always going to be able to count. You're not always going to want to graph these things out and count the lengths of the sides. It's going to be a lot easier to just calculate the lengths of the sides. Okay, so let's go ahead and do the same thing for the length of AC. Now notice AC is a vertical line. So now you're going to take the difference between the y values. Okay, so we're going to go with absolute value of 4 minus negative 2. Well, again, minus a negative, that's going to give me a 6. Or I mean a positive, sorry. And then that gives me absolute value of 6, which just happens to be 6. And yes, we had already counted that here, right? Okay, but this whole side here is 6. So now, if I want to figure out the Pythagorean theorem, well, one of my legs is 8. The other leg is 6, so I square that. And that's going to give me that hypotenuse. I'm just going to call that h squared. So this is 64 plus 36 equals h squared, or h squared equals 100. Now, be careful. Keep these things as equations. You set it up as an equation. You solve it as an equation. Okay? An equation basically means that you have one equal sign, two sides. And notice the whole time, it's one equal sign, two sides. Now I've got to solve for h. Well, to undo a square, you do a square root. So here, I'm going to square root both sides. So h is equal to 10. It can only be positive, and I'll talk more about that later with you, but right now it's got to be positive because we're talking about the length. Okay, so h is equal to 10. That's the length of our... Now, I'm going to relate this later on, the Pythagorean theorem. Actually, yeah, the Pythagorean theorem is basically the distance formula. The thing about the distance formula, though, is that when you are finding the distance between 2 points, like A and B, you won't actually know the length of each of these sides. So instead, you're just going to have to use these 2 points and do what we did. So I will come back to that when we start to talk about the distance formula. All right, let's talk about midpoints and segment bisectors. All right, so The midpoint of a segment is the point that divides the segment into two congruent segments. So I'm going to highlight that. And there's our midpoint right there. It's in the middle. And I know it's in the middle because I have these tick marks. These pink things, I'm going to highlight them in pink. These are basically what I call tick marks. I'm going to do a little key over here. So I call these tick marks. And they show congruence. They show congruence. So if things are congruent, they're going to have these tick marks. Congruent means that they're the same length. Sometimes they might have 2 tick marks or 3 tick marks, okay? But it basically means that they are the same length. They are congruent. Next, we're going to talk about a segment bisector. So a segment bisector is a point, a ray, a line segment, or a plane that intersects the segment at its midpoint. So it's any of these things. So like point M is also a segment bisector. It is in the middle and it is bisecting it. So it can be a point, but it can also be a ray or a line segment. Notice here, we've got line DC or line DM or whatever you want to call it. They call it line CD. Okay, and that's also a segment bisector. So a midpoint or a segment bisector, it bisects a segment. It basically means that it cuts it into 2 equal parts again. So let's write that down. Bisect means to divide into 2 equal parts. Root word there being bi, which means 2. Okay, so here we have a line, but you could have a ray bisecting it. Notice you got those tick marks there. That shows you that AM is the same length or congruent to MB. And that's what all of this is saying right here. AM is congruent, segment AM is congruent to segment MB. Or in other words, the length of AM is equal to the length of MB. These are basically lengths. All right, so example 1. In the figure, we know that PM is equal to 1.8 millimeters. I'm going to write that down. Identify the segment bisector of segment PQ. So let's do that. Well, what's right in the middle? Well, I can see these little tick marks tell me that PM and MQ are the same length. So actually, I'll go ahead and I'll write that 1.8 millimeters because those tick marks tell me that they are exactly the same. So the thing that's bisecting them, well, point M is in the middle, and I've got this ray sticking out, right? So I can say that the segment bisector is ray MT. Remember, a ray, you got to use the endpoint first. Then I have to then I have to find the length of PQ. Notice there's no segment on top there. So I'm just looking for the length of PQ. So from P to M is 1.8. M to Q is exactly the same. So PQ is going to be twice of that. Twice PM, right? So PQ will equal 2 times PM. Or 2 times 1.8. Which is 3.6 millimeters. Both of those are your answers. You have 2 answers there. Okay, example 2. Now let's use some algebra. So we know that point M is the midpoint. And we know that. They didn't even have to tell us that because these 2 have tick marks. So we know that those are equal amounts or they're congruent, equal lengths or they're congruent. We're going to find the length of AB. Well, I know that AB, the length of AB, is going to equal the length of AM plus the length of MB. And by the way, AM and MB are exactly the same, so I could have also written it like this. 2 times AM, right? Because they're exactly the same. Well, before I can calculate any of this, I need to figure out what x is. Look, I don't have any idea what x is. What I do know, though, is that AM has to equal MB. So I know that the length of AM is equal to the length of MB. So I know that 3x minus 4 is then equal to 2x plus 1. I can now solve for x because I have an equation. So I will solve for x by subtracting 2x on both sides. That leaves me with x minus 4 equals 1. And then I can add 4 to both sides, leaving me with, I'm going to come over here to, I can fit it, that x equals 5. So now that I know that x equals 5, I can go in and I can figure out what AM is. So this is 3 times 5. Let's see, I'm going to write AM equals 3 times 5 minus 4, or 15 minus 4, which is 11. And so I know then that AB is equal to 2 times 11, or 22. I'm going to go ahead and circle that. Okay, this will probably be the easiest construction that you do. You're going to construct a segment bisector of segment AB by paper folding. Then we'll find the midpoint. So this is super simple. We're going to draw segment AB. So just on my paper somewhere, I'm going to draw the segment AB. You're going to fold the paper. So you'll fold the paper so that B is on top of A. You've probably done this many times. So I'm just going to fold my paper and try and get B on top of A. I'm going to put a fold in it. And voila, that right there is the middle. I know, it's like rocket science, right? So we labeled the midpoint M. So label point M. Compare AM, MB, and AB. Well, basically, AM is going to equal MB, right? So these two are going to be exactly the same. They're going to be congruent. And both of those are just equal to half of AB. So AB, if I cut it in half, would be equal to AM. All right, so that brings us to the midpoint formula. And I pretty much already did this in the exploration with you. But the midpoint formula so the midpoint formula basically shows you how to find the midpoint of any line segment out there. And the coordinates of the midpoint of a segment are the averages of the x coordinates and of the y coordinates of the endpoint. So that is key right there. Yes, you can always use slope as well to try and find that. The challenge with that is going to be, if you did use those slope triangles, you were going to have to graph this first in order to use it. Instead, it's just easier to use those endpoints. Maybe I just give you A and B and we haven't graphed them. It's easier to use those endpoints and find the averages of the x and the averages of the y. So I'm going to highlight that. So given that, A had points x1, y1, and B has points x2, y2, then the midpoint has these coordinates. So that is right there is your midpoint. Okay, so that's our midpoint formula. This is super important. I need you guys to learn that by heart. You can also highlight this. This is exactly the same. Any point you can call x1, y1, and x2, y2. So here's an example. The endpoints of AB are this and this, A and B. Find the coordinates of the midpoint M. I don't want to graph this. There's no reason for me to graph this. So I'm going to go ahead and just use the midpoint formula. So once again, the midpoint formula, I'll use a capital M for that. It's the averages of the x's. So it's x1 plus x2 over 2. And it's the averages of the y's. So it's y1 plus y2 over 2. And that'll actually give you both the x and the y coordinates. All right, so, and it doesn't matter which one you choose as your first point. So x1, y1, and this will be my x2, y2. So to find the midpoint of segment AB, that's like a subscript. Okay, I'm going to add together the x coordinates first and divide by 2, so -8 plus 5 divided by 2. And then I'm going to do the same thing for the y coordinates. 7 plus 1 divided by 2. So -8 plus 5, well, that's -3 halves. And then 8 over 2. Or in other words, this is -1.54. So that's my midpoint right there, and I didn't even have to graph it, which is pretty cool. All right, so that was A. Now let's do B. The midpoint of segment PQ is this. One endpoint is this, is P. Find the coordinates of the other endpoint. So this is a little bit more tricky. You kind of have to do these individually. I'm given the midpoint, so I'm given this piece right here, and I have to go back and I have to figure out, given the fact that I only know one endpoint. So I know x1 and y1, but I don't know x2 and y2. So for Q, I'm going to go ahead and just say that'll be x2, y2. Okay, and then I'm going to basically figure out my x coordinates and my y coordinates. So what I mean by that, what's a good way that I could write this? Let me do a little divider here. So for my midpoint, I usually know my midpoint is some values. And here I know that it's 2, -3. I'm going to go ahead and just say that I've got an x coordinate and a y coordinate in my midpoint. Well, the x coordinate is always found by doing x1 plus x2 over 2. So what I'm going to do here is I'm going to set the x coordinate at my midpoint equal to this right here. And I'm going to solve for the x2. And I'm going to do the same thing for the y. So the y coordinate is the average of the y's. So I'm going to take the y coordinate that I have, and I'm going to set it equal to this little formula right there, or basically the average of the y's. Then I'll be able to solve for the x2 and the y2. Okay, so I'm going to do these separately, okay? So I'm going to start with x coordinate. I'll highlight that in yellow. I'll keep this nice and color coordinated. Okay, so I know the midpoint. The midpoint has my x value of 2. I'm going to set that equal to, well, I know my x1 is 4, but I don't know my x2. And I'll divide that by 2. And now it's a simple algebra problem. So I'm going to multiply both sides here. I'm going to get rid of this 2. So I'm going to end up multiplying both sides by 2. So I end up with 4 equals, and then these 2's reduce. So this is 4 plus x2. And then I'm going to solve for x2. So basically I'm going to subtract both sides by 4. So I end up with x2 is equal to 0. Okay, I'm going to do the same thing for the y coordinate now. I'll highlight that in pink so that I have this nice and color coded for you. Okay, so the midpoint, the y coordinate of the midpoint is -3. y1, I know it's 1. y2, I don't know. That's what I'm looking for. Divided by 2. So I do the exact same thing. I solve for y2. So I'm going to start by getting rid of the denominator of 2 by multiplying both sides. Undoing that 2, right? These reduce. They're gone. This gives me a -6. Oops. Equals 1 plus y2. Solving for y2, I'm just going to subtract 1 from both sides. I get y2 equals -7. Okay, so what I've just gotten is my y-coordinate and my x-coordinate of that other point. So I know that point Q is 0, -7, and that's my answer. All right, moving on to the distance formula. So the distance formula becomes super important. It basically is the Pythagorean theorem. The difference between, and let's look down here, the distance formula and the Pythagorean theorem, notice they both are involving these like right triangles. We're trying to find the length of AB, which is really the hypotenuse, this hypotenuse C. Well, the Pythagorean theorem always assumes that you know the lengths of your legs. You know A and B. When you're just given two random coordinates, you don't know the lengths of the legs. So I'm going to go back to that first example that we did, and I'm going to grab those coordinates. So the coordinates of B were -5, -2, and A was 3 and 4. Okay. So I'm going to just write over here that A is -5, -2, and B is 3, 4. And we basically used the distance formula on that example because really what we did was we had to find the lengths of those legs first. So that's what the distance formula does. The distance formula has you first find the lengths of your horizontal leg and your vertical leg. And it just does it all in the formula itself. So I'm going to relate the distance formula to the Pythagorean theorem, okay? And I'm going to do that all right here. So if I'm trying to find AB, that's the hypotenuse, I can square that. And that would be equal to the square, AC squared, right? The square of that leg, plus the square of the other leg, which in this case would be BC squared. I probably should use different letters because this might mess you up from the other side, but I think we'll be okay. All right, so I'm looking for AB here. Well, I don't know AC and I don't know BC. So what I need to know here is what is C? Well, C truly is this X value that's right above it, 3, and this Y value that's on the same level, which is -2. So when I'm looking for AC, what I'm really doing is I'm taking this A value, this X value of A, and this X value of C, and I'm finding that distance. Okay, so I'm really taking the difference between x2 and x1. So I'm taking x2 minus x1, and I'm squaring it. That's my AC. Plus my BC, I'm doing the same thing. I'm taking now, because it's a vertical line, I'm taking the Y values of B and C, taking the difference of them, and squaring it. Now, notice I'm not using the absolute value symbols, because when you square a number, it becomes positive. So the absolute value can kind of be thrown out in this case. All right, so this is basically going to be y2 minus y1. And when I square that, it'll give me my positive answer. So really, this is AB squared is equal to the change in x's squared plus the change in the y squared, right? Or the length of my horizontal leg and my vertical legs, both of those squared and summed up. Now, how do I get AB by itself? Because it's being squared. Well, you take the square root. So AB truly is the square root of x2 minus x1 squared plus y2 minus y1 squared. And that right there is the distance formula. There it is. So let's go ahead and let's finish this off, and you'll see that we get the exact same thing if I use those points from our exploration in the beginning. We get the exact same thing. All right, so we get AB is equal to, well, x2 was 3. Actually, it doesn't matter where you look here. x2 is 3 minus x1, which is negative 5. That should look really familiar. Squared plus, and the y2 is 4 minus the y1, which is negative 2 squared. Again, I just transposed these from the front exploration that we did. I just grabbed those same exact points. All right, so this is really, well, minus the negative becomes positive, so this is really 8 squared. Minus the negative becomes positive, so that's really 6 squared. So AB is equal to the square root of all that. And the square root of all that, well, that's 64 plus 36, so that's 100. So that means that AB is equal to 10. Just like we got in the beginning when we used Pythagorean Theorem. Right, we found the lengths of our legs first, and then we were able to use that Pythagorean Theorem. Well, why even bother? If you're given coordinates, just use the distance formula. It really is the Pythagorean Theorem. Without us having to figure out, separately what the lengths of the legs are. It's built into the formula. So that's the Pythagorean Theorem. Okay, that's the distance formula given using the Pythagorean Theorem. They're the same exact thing. All right, your school is 4 miles east and 1 mile south of your house. So hopefully you guys have some idea of your geography. So north, then east, then south, then west. So it kind of looks like that, or does look like that. Some of you guys learned like never eat shredded wheat, never eat soggy waffles. I know there's a whole bunch of things that you can make up. So I'm going to go ahead and draw myself a picture here. So here's my house. So it's my house and my school that I'm comparing here. I'll label that, how about H for house. So your school is 4 miles east. Okay, so I'm going to go 4 miles east of my house and 1 mile south of my house. So how about I come down like this and put a 1 there, and that's my school. This is hard. I'm going to put an S for school. Okay. You bicycle 5 miles east, then 2 miles north from your house. Okay, so this right here from my house, in relation to my house, I'm going to put a negative because it's down. I'm going to say that this point is 4, negative 1. Okay, and then I bike 5 miles east. So I bike over here 5 miles east, then 2 miles north from my house. So I went right 5 and up 2. So I'm going to call this right here, this is my friend's house. Call it F. And the coordinates of that will be 5, 2. How far does your friend live from your school? So the question is from school to my friend's house. Well, notice I'm really just finding the distance between two coordinates, 5, 2 and 4, negative 1. Or in other words, I'll call this x1, y1, and I'll call this one x2, y2. So I can just use the distance formula for this. So I know that SF, the length of SF, is going to equal the square root of the change in the x's, which is x2 minus x1, and then I can square those, plus the change in the y squared, y2 minus y1, and I can square those. So by going from x2 to x1, that's really going to give me this horizontal length. And from going from y2 to y1, that's really going to give me this vertical length. So really what I am doing is I'm finding the lengths of the legs and I'm squaring them. Okay, so let's just go ahead and let's do this, and it's super quick, and we just plug in the numbers and we do the math and it's over and we don't have to think too much about it, which is the beauty of distance formula. So I'm going to take x2, which is 5, minus x1, which is 4, and I'm going to square that. And then I'll add to that y2, which is 2, minus y1, which is negative 1, and I'm going to square that. 5 minus 4 is 1 squared, plus, and then 2 minus a negative 1, well, that really becomes 3 squared. So now what I've got is 1 plus 9, the square root of that, or the square root of 10. The square root of 10 is an exact answer. However, your textbook might give you an approximation. And if they do, this is my preferred answer. But if they do, then you just go into your calculator and you just do the square root of 10, which ends up giving you approximately 3.162. And these units were in miles, so we're going to use miles.